So, one thing that I'm going to suggest that we do something else, but I just want to something that Jeremy said at the very, very end there was sort of interesting to me. It was something I wondered about before in connection with this question more generally. To what extent do mathematicians agree about what's a theorem, what's a lemma, what's a proposition, not a theorem, and what's a corollary, say? Because I think many people have the intuition that those terms are supposed to be tracking something very much like what one calls death. But in any case, that's not something that you need to spend any time on. So this note passing that was going on was actually a suggestion from Penn that strikes me as a good one. That maybe since we have seen a number of statements of what one might take mathematical depth to be, that it might be a good idea to start by just trying to regiment this a little bit and write down some of the things that we've said. This isn't good. Some of the things that we've said might count as depth, and so I'm not going to remember all of these, so I need help. But I do remember the one that Jeremy just put up on his last slide. So a result that's somehow hidden and with significant
Organizational is the one
organizational. Did you say power or capacity?
Power.
Jimmy, do you want to try to put in some sense your answer to Jeremy Heiss in a similarly compact expression? I won't write your name next to it, so we won't forget immediately that you did it.
I would say, I guess, also this would involve the remark I read from Ghost too, of something showing up in a range of different, apparently very different, or apparently very diverse, let's just say different, something showing up in a range of contexts which appear on the surface extremely different.
Surprising connections between things that seem to be unrelated.
Yes, yeah, that's better. Surprising connections between things that appear to be unrelated. Yes, say apparently unrelated contexts.
Okay. I wonder, I'm actually going to write down number 3.
And I should say maybe usefully, right, not just sort of incidentally.
I wonder, though, if something usefully appearing in many different apparently unrelated places is different from something that shows connections between many apparently different areas of mathematics. Yeah, you might think that the integers show up all over the place.
If I have to, true. If I have to choose one, I guess I'd say connections then,
okay.
Rather than usefully appearing.
Universality. So that's just mystery worker.
Something connecting many different apparent.
What I would like to know, what are we talking about when we say something? Is it a fact? Is it a theorem? Is it a theory? Is it a definition? I mean, what are we really talking about here?
Yeah, that's good.
Talk about a think we are talking about all of those.
Yeah, I think each
All
of
of
those
those.
When we talk
in
about
their own
deep
way
results,
can
all
have
of
this,
about
this
the
feature.
proof, when we talk about deep concept.
Although it seems to me that one probably does want to at least reserve the right to say that when I say a theorem is deep, I mean it in sense one. When I say that an area of
Sure,
mathematics
sure,
is
yeah.
deep, I mean it in sense two. When I say a proof is deep, I mean it in some other sense perhaps. And so this is, so I was writing down as we were going along this afternoon, trying to find, I could identify places where I thought, so one of the questions is there significant agreement on which examples are deep and not deep? And two is there agreement about what makes them deep? And I was trying to identify places where I thought that there was probably disagreement, because that may be the most interesting place to discuss things. So at least one place where there might be disagreement is Bob thinks anything to do with polynomials can't be deep, and a lot of people think that Galois theory is quite deep. And Galois theory, at least historically, has had a lot to do with polynomials, and so one might wonder.
Well, yeah, but Jeremy's point was that
Yeah, right, of course.
that's exactly the wrong way to think of it.
Yeah, that's sure.
Bob triumphant.
I think one area of disagreement might be whether the proof is long or short, because I hear comments that some feel that deep is long and some feel that deep is short, or at least with those help. I don't know if there's any agreement with that. Or whether it's easy or hard is another issue. Or can easy things be deep? I think they can.
Well, maybe it's often that something is deep, and it makes something that has seemed hard suddenly easy.
Yeah.
If a concept such as the group concept is brought in order to clarify and simplify.
So
I would suggest that the depth of a theorem would be the number of layers of concepts required for sort of this maximally insightful proof. Whether that means shortest necessarily.
Yeah, I like that. I feel that way.
But for the depth of a theorem?
The depth of the theorem, you look at sort of all the possible proofs. Some of them may be short, some may be long. Is that one from the book, and how many layers of concepts need to be built up to give that proof?
So depth is the number of concepts required in the optimal. I'm not sure how to characterize that as.
Layers of concepts required for a maximally insightful proof.
Okay. John, you're the.
Well, I like three so much, I don't have much to add to that, except to say it need not be many layers. If the concepts are well chosen, maybe only 2 or 3 layers can constitute a deep proof.
So that's compatible with this insofar as it may only take 2 layers for the maximally insightful proof.
Yes, yes.
I should add that when I say this, I have in the back of my mind the one book I read that relates the Sum Up, which is the one by Lakoff. I forget the title, but sort of cognitive science and mathematics. So he builds up the concepts and get you to EDI 5 + 1 = 0. So I'm thinking of this sort of process that he does for that equation being applied to this situation.
But so what makes something deep? So you might have thought that a measure of the depth would be the number of layers of somehow distinct concepts required for a maximally insightful proof. But then
So merely the existence of extra concepts. 2 or 3 might be enough. For instance, existence of transcendental numbers. You only need the concept of countability and some idea of how to enumerate polynomial equations. I'm sorry to say. to prove the existence of transcendental. So only 1 or 2 concepts are required there. But it was hard before you thought of those concepts.
Yeah, and it seems to me that it's not so much the number of concepts as the maybe the disparity of the concepts, the distance between the concepts, that it can be more deep if there's two concepts that are quite far apart that are both involved, than if there's two concepts that are not so, then if there's 3 or 4 concepts that are all quite closely related to each other.
So the,
Necessarily that, it's not necessarily the number.
Yeah, accountability is such a powerful concept.
It's the thickness of the layers they're worried about.
Well, it's two
Yeah.
showing up with the layers, right?
disparity in multi, so I should say this is 2' / 3 double prime.
Well, it's that we want layers that are deep in the sense of two.
Okay.
So over lunch, we were discussing this picture of proof is sort of you're diving down from the surface, whatever that is, and then some depth, and then coming back up, and then Andre mentioned, well, you may have to dive down from several different places and meet up somewhere, and then eventually make your way back up. And so we said, well, maybe the depth is the total length of all of those tunnels underground that you're digging to end up in the place you want to be.
I mean, it does seem to me that there are at least 2 different metaphors of depth that are getting drawn on here. One is the metaphor of something being deep in the sense of somehow hidden or difficult to get to, and the other being deep in the sense of somehow lying beneath other things. And so I think maybe number 1 is the sense of difficult to get to, and 2 is capturing a sense of somehow being an underlying connection between things. Now, I'm not saying that these are unrelated to one another or that the sense in which we use the metaphor, but the language seems to be a little bit different in each of these cases, right? So Jeremy, in a question of Jamie, asked about whether there were these underlying connections between different areas, and whether that was the important thing. But then it's not clear that something being underlying connections have much to do with them being somehow hidden from us. Right. So at least one question related to number 4 here, whether or not we can think of depth as a likely objective feature, or something essentially tied to our interests, abilities, and so on, is related to something else that's come up a few times, which is whether or not something can continue to be deep, or whether something necessarily continues to be deep, or if it can stop being deep in light of further developments. And you might think that something that's hidden, once it's revealed, is no longer hidden, and that metaphor would suggest that things need not continue to be deep. Of course, Jeremy pointed to these examples from Gauss, where even after the proofs were known, they were so hard to read that it wasn't clear that something had been revealed above and beyond the truth of certain propositions. But one way or the other, if what we're caring about are sort of these underlying connections between different areas, it does seem as though our epistemological state with regard to, say, the propositions or theorems in question doesn't matter as much. Things could be connected or not. Once we discover they're connected, that doesn't somehow disconnect them. I'm not giving a talk, but I don't know. Yeah.
Well, one of this relates to John's talk, having to do with the fact that sometimes these things can keep manual. I said something like this too, although not as systematically or as thoroughly as John. Things keep cropping up, right? And I don't think I wouldn't want to say this is constitutive of being deep, or that this is what being deep is, but it's something which is, so to say, a kind of a regular sign of depth, or it's something we often expect from, at least many times when we describe something as deep, we also sort of anticipate that it will continue to surprise us. And the reason I mention that in part, even though it's not constitutional, you're not saying, well, this is what it is to be deep, it's to give rise to these things. It's rather that does give a foothold on a kind of objectivity because it involves a prediction that you can be wrong about, right? You can sort of say, well, you know, I really think this pulls all these things together in a way that's going to give, what was the phrase I think Piano used for logicism, you know, give stilts and wings to invention. And then, you know, you might later say, well, you know, maybe that was a little over enthusiastic. And also that would, you know, give a way of giving a kind of an intermediate response to the question, is this tied to our interests and abilities? In a way that I think Kat suggested. In certain cases, at least, you can say, well, let's just fix the facts, what our abilities and interests are, and then say, relative to those abilities and interests, right, certain things we expect, and among them are that the things we count as deep will manifest, at least often in this particular way, maybe not a necessary condition, but one that we tend to find. So that this might not, maybe there would be an asterisk beside this one or something, because I'm not suggesting it's constitutive of being deep, but rather it's something we expect to find in the things we describe, in at least many of the things we describe as deep.
So something we expect of deep mathematics.
So there's a kind of interesting opposite to that, which especially applies to facts, which is the really unexpected one. So I mean, when John says transcendental numbers, right? I mean, this is a shock. You think, come on, basically, numbers are okay, handled by disparate logic, here. Oh no, no. And then suddenly someone tells you, well, all numbers are like that. Right? So this is a transformative character about some discoveries that I might think count as deep, at least what the fact that these things exist is that we go, we didn't know it was going to be like that.
So transformative is a good word, actually. The NSF likes this word, transformative.
Supporting grant applications.
Sorry, I don't know if that sunk so low.
No, I mean, it's a good term, actually.
So as somebody who has a really awful historical sense, I'd like to look at a historical example of the Greek becoming aware of the existence of irrational numbers, which for us doesn't seem all that deep. I mean, we teach it to our freshmen often, or in our gen ed math classes, the irrationality of the square root of 2. So that, is that a case where something, I mean, that was, I think, deep from the Greeks. It was why at least these apocryphal stories about drowning the person who transmitted it to others came about. And I said apocryphal, I didn't put it accurate. I'm not trying to perpetuate the myth, but nonetheless, it sort of suggests that they wanted to submerge somebody. There was a feeling of wanting to submerge the result. Yeah, return it to the deep where it belongs. But it really isn't any. Is it still deep? I mean, it was deep in a sense because for them everything was commensurable, and if I'm not inaccurate, it was there. And now things aren't commensurable.
I think the proof of the independence of the parallel postulate is deep in that sense more than it is in any other sense. Because by the time it was proven, more or less everyone agreed that it was probably independent. No one didn't prove it. And the mathematics behind it is good, but it's not as the mathematics isn't as difficult as the work on elliptic functions was. It was really the independence of the parallel postulate brought about a transformation in how people thought about geometry, or how people thought about mathematics in general.
That's in some sense also true of Gödel's work. There were ideas around, there were other people who should have been able to discover these, what we talk about there were other people who should have been able to discover Gödel's theorems, but they didn't have the concept, it's just that the question sort of wasn't there in their minds, and it was Gödel that thought to ask the question, and that was, it's not that it's technically that difficult, but people do much of that equally difficult technical work at that time in logic, it just didn't, thought to ask these questions.
So for the transformative things, are they the kind of things that are going to have to hidden and not continue to be deep? Or are they going to continue to be deep because they told us some, say, they exist as transcendental numbers? As transformative, but also it fundamentally informs how we think about numbers ever since. So I'm inclined to say it continues to be deep, but given the word's transformative, right, it ceases to be transformative after it's occurred. So are we thinking of transformative things as that's more like the hidden, where it's not necessarily, it's if anything going to lean against objectivity?
You might think that transformative, though, could also go along with significant organizational power. And significant organizational power may have something to do with the way in which, independently of of us, the way in which the areas of mathematics somehow relate to one another. And so it was transformative insofar as it revealed the ways in which methods from one area could be applied to problems in another area, and so it completely changed the practice. But the way in which it did so was to reveal some significant organizational principle that wasn't apparent to us before.
I would make a remark just to do with this transformative. I think our conception of depth is really time dependent in mathematics. I think this has to do with this transformative nature of some deep ideas. Yeah, for example, think of the epsilon delta definition of continuity, right? I mean, this was a very transformative event in the history of mathematics, and now it's something that we take totally for granted. I think it's an objectively deep idea when it appeared, it transformed our whole field, but now somehow we take it for granted.
So maybe it would be useful at this point to sort of sort these a little bit along the lines of, so question number 4 and Bob's distinction between stuff about us and stuff about the math, and then maybe also stuff that's historically or somehow otherwise contextually contingent, and stuff that we might think of as non-contingent.
Well, there's an orthogonal distinction, which you mentioned earlier, which is stuff that seemingly manifests depth as opposed to stuff that is either what it is to be deep or responsible for making something.
Mm-hmm. Okay, so
that's another dimension along which they could be sorted. So one could think that being transformative reflects depth without constituting it or being what it is in virtual relation, something else. That would allow the fact that transformativeness is transitory.
Surprisingness maybe of that character.
Surprisingness as well, yeah. And fruitfulness, potentially.
So transformative, maybe a 5 prime is fruitfulness. So there is presumably a relationship between, but it's not, they aren't coexistent. So, okay, so maybe we should sort in 2 steps then. So maybe I'll put a star next to the bits that we think are just about the math. I'll put I want to say frowny face, but that might judge things too an exclamation point next to the bits that seem to be about the people, and then a question mark, and again next to the things that are we think contingent. So you may have more than one symbol next to each of these, and then we can come back to the ones that we think might be constitutive versus the ones which we might think of as what we expect of deep mathematics. Okay, so I guess this exercise with this audience is sort of embarrassing for me. I wonder, would people tend to agree that hidden is essentially about us? Okay, so I'll put an exclamation mark And presumably that's also potentially context dependent, at least potentially context dependent. Okay, so I wonder both significant organizational power and something connecting many different apparently unrelated areas. This word is going to cause us problems, I guess, but.
Well, it interacts with hidden
It
to
interacts
some
with
extent.
The apparently.
Apparently unrelated, and I
So-
mean, obviously they're not identical, but.
So I should put some of these. So Jamie, there was something that you said about the idea, and I think that this relates to both connecting different unrelated areas and also significant organizational power, regarding the way in which how we organize mathematics into subject matter is something that's essentially about us, and not something essentially about the mathematics. And that if we were different, say if we were logically omniscient, it would just be a whole bunch of sentences in an appropriate language, and we wouldn't have any need to carve them up as these
Well,
being
yeah, I realized that after reflecting on what I said that I should have been more careful. In part because I realized afterwards that I basically asserted one side of one of the questions that we were supposed to be discussing, but rather dogmatically. But also I realized that I was asserting something that I don't myself actually believe. It happens more often than I'd like to admit. But I think that there are. I like to say that there's a kind of a distinction that I'm trying to find ways to finesse, to get around, of thinking, well, there are these things that have to do with us, they have to do with our interests and so forth, and as a result they're somehow superficial or contingent or accidental. And I'd rather, I'm looking for something to say, yeah, there are these things which do depend on us. There are, in certain ways, artifacts of the way we set up the subject matter, the way we approach certain things, maybe also certain psychological facts about us. But then I want to say, once those parameters are set, they, so to speak, create certain facts which have, it sounds a little too mystical, but they have a life of their own, right? Once you say, all right, this is the way we set it up. These are the ways that we classify it. All those have to do with our interests. If we were without vision, we probably wouldn't do geometry. Or at least in a very different way from the way we do it now. But the fact is, we do have vision, we do set things up this way, and given all of that, then yeah, certain facts which are objective relative to that can come up. And so I figured I should, make that clearer, that I don't, by saying these things are sort of dependent to a large extent on our interests, I don't think that means they're less objective, or that they have to be.
So one might even think that something like the following conditional is what's deep. If one sets things up in the following way, then the following theorem, say, has significant organizational power, and that by itself is.
Yeah, where what counts as setting up could be, quite vague and context dependent. It has to do with the practices and the education system and what the different schools are and so forth. I mean, this could all be quite hard to nail down precisely, but nonetheless not less real for any of that.
So then it sounds like there aren't significant objections then to putting stars at significant organizational power.
Depends what you mean by significant.
Good.
There are lots of things that have organizational power, and people say, but that's about something trivial that nobody cares about.
Okay, so we'll take a photograph of this at the end, and it'll be perfectly clear to everyone who understands what we were talking about.
You color coded as well.
Yeah, well, I could use this black marker and then this gray marker. Okay, so perhaps organizational power is okay, but what makes it significant has to do with us in a more troubling way. Does that? found a disagreement, or are we reasonably comfortable? So I don't know how to think about this bit of this.
I think there's no such thing as a maximally insightful.
I mean, both bits are problematic. That is to say, insightful and maximal. And maximally, even though the effect is somewhat dulled by the before maximally, still has a kind of winner-take-all quality that probably is appropriate here. Even, as it were, a really insightful one that isn't maximal is going to contribute to whatever the quality is that we're trying to identify here. Then, of course, you've got insightful.
As a point of clarification about 3, it's intended to, its leisure concepts required for a maximum insightful proof tells us that whatever is proven is the thing that's deep.
So there was, this is why there's 3 prime and 3 double prime, right? So one way of understanding 3 was that it just gives us some sort of measure of depth. So you give me a theorem, I tell you how deep it is by counting up how many layers of concepts are required for the maximally insightful proof. So maybe it's 17, and then you can go and say, well, that means this is deeper than this other thing. But then there were these suggestions that that's just the wrong way of thinking about it. The important thing about what's going on here is that really the emphasis on layers of concepts, and what has to be careful, because you can always layer on a whole bunch of concepts that just spin their wheels and don't do anything. But you know, if you look at, say, the proof in the book, and you ask how many layers of concepts are there, the fact that there may be multiple layers is what makes it deep, or the fact that those layers are unrelated to one another.
Well, I mean, 3 is also distinct from 1 and 2 in the sense that it looks like it. One of the things we talked about is, right, what are we applying deep to here, right? Theorems, facts, proofs, concepts.
Areas.
Yeah, and it looks like 3 is just theorems.
So say again your list.
Okay,
Theorems, facts, proofs, concepts, areas.
yeah.
Approaches.
Yeah, methods we've had, yeah.
3 could be about concepts too. If the concept needs layers in order to be defined, layers of other concepts in order to be defined.
Definitions.
So my concern with 3 was just that a given statement or theorem has any number of different proofs, different ways of expressing the proof. And some of those can surely be stated with a minimum number of concepts, maybe even just sort of logic concepts. And maybe like was said, you could also write a proof which brings in a bunch of other concepts that aren't really necessary there and don't really add any insight to it. They're sort of extraneous. So it's trying to find some way of expressing the balance between that. Something ideal about that proof that is somehow going to determine the depth of that theorem. I don't know if that's what it's saying. That's what I mean.
So
So if we have a theorem and all we have is a terribly uninsightful, like reductive, it doesn't help us understand why it works. And then somebody comes along and finds one of these lovely conceptually layered, maximally insightful proofs, and we give them tenure. Do we say that that theorem went from failing to be deep to being deep, or was it deep all along?
what did we discover that was deep? We may have not known, because we didn't know what the maximally insightful proof was. We may not have known how long it would be, or rather how many layers of concepts it would have.
I guess I'm sort of asking, is depth in that sense going to be relative to the structure in which the theorem resides, like in the way it's presented to people, or is it, in in and of itself deep, sort of regardless of whether we've gotten around to linking it up correctly.
So maybe following up from that, if we ask the question, is Fermat's last theorem deep? We may not actually know the maximally insightful proof, you probably don't. Plus, is it really a deep theorem, or is it just the proof? I think your argument is the proof is deep because it's useful for lots of other things, but the result itself, I think a lot of number theorists would even say it's not necessarily, it doesn't really do anything for us. So where does that fall into these?
Well, I'd say we don't know what the maximally insightful proof is, but we have somewhat insightful proof now, which has certain layers of concepts, such as modularity is one of the concepts involved that make it clearer, or it's the only way we have access to it at the moment.
We may have a bound on the depth of it without knowing.
Yes.
the
Well,
depth of
yeah, I
it.
mean, maybe we don't yet know the maximum insightful proof. Do we have to know it? I mean, what if there are, many fewer layers and they're useless in the maximally insightful proof of Alasdair's theorem? What does that tell us about this? Has it suddenly become a deep?
Yeah, I think it is. I think depth is an appraisal contingent on our current understanding of that. I would say.
Yeah, so one family of concerns I have about this way of thinking is the individuation of these different entities. So for instance, how do we individuate two different theorems?
Over here.
Yeah, this whole family, which I take it this is in the background of most accounts of depth. One needs to be able to tell the difference between two different theorems. And often what happens in mathematics is we're very good at enlightening small or maybe large differences between theorems, so that we think that, to put it in the terms of layers of concepts, how do we tell when we have two different layers of concepts? Or maybe there's another way of articulating or expressing these layers that in some sense is equivalent, but isn't qua counting, and it maybe isn't in other ways, but it's useful, or we're accustomed to playing things out this way. So if you think of different analyses of the concept of continuous function, for instance, they're going to involve different concepts. Are they all somehow the same? How do we tell the difference? For me, I don't know the answer to any of those questions, but I worry that trying to be super sharp about any of these matters requires having at least some grasp of how to address this question of individuation of these, whatever these are.
I mean, I think there's a way to make the point even sometimes more poignant, which is that often the deepest results are the ones that show us that concepts we thought were totally different are actually closely related or even the same.
Good.
Okay, so Andy, do you think that this worry comes up already in one and two, or is it this family in terms of layers of concepts that it becomes most acute?
Well, it certainly affects two, because I don't know how areas are individuated. Maybe it's affecting.
It's probably hard to give a rigorous definition, but if you see two different areas, just know that they're different. Think of analytic function theory and number theory, right? These are certainly different areas, but I would say, for example, the proof of the prime number theorem is deep because it connects these two areas, which really are different areas.
I go back to when I talked to Ken Ono one time, and he told me that really Fermat's last theorem was about elliptic modular functions. That I just misunderstood it all along. That if I really understood the theorem.
No, this is what number theorists say. They say in this Fermat's, this fact, Gauss famously refused to work on it because he said there are 100 problems like this that you can come up with. But then I think it was Riebe who discovered this connection to this modularity, and I think this, so that was a big deal.
Okay, so maybe I should do this. So it seems as though all of 3 prime and 3 double prime require us to are specifically about theorems, and they require us to say something about which proofs are the ones that we care about for this purpose. And so you might think that all three of these are somehow exclamation point question mark because of we don't know how to spell out what maximally insightful means.
I just think that's awful. I think it's a really poor choice of words, period.
Maximally insightful.
I don't think that we ever are sure that we have maximally insightful proof, despite Erdish and his proofs in the book. Those were Erdish's opinion of what the proofs in the book.
And proofs in the book are ones that everyone agrees.
Well, but, right.
But it's not in the book unless everyone
Unless
says
everybody-
that.
I'm not sure everybody ever agrees that something is, I mean.
Yeah, why not just cross out this word maximally?
So maximally is,
It's
of
much
course,
better. No,
Yeah,
insightful
yeah,
can stay.
Exceptionally insightful.
Insightful is.
Or more than averagely insightful.
Well, insightful is insightful.
Yeah,
highly
yeah,
insightful,
yeah.
highly insightful.
Yeah.
For example.
Okay.
Maximally
There
is,
is-
bothers me.
Yeah,
Yes, it is.
But isn't insightful just a synonym for deep?
No.
I don't know, it's one that explains the theorem.
Yeah,
No, I think it might be deep even if we don't understand it.
Yeah.
But-
even if it does, this tells us that theorems with deep proofs are deep, which is a substantive claim. Because you
Oh,
might
yes.
think you can have deep proofs and not, right? So, and if it doesn't say that, that should be up here as well.
Okay, so
Well, there's, not up here, but there's a question about the relationship between these different things, deep ones and non-deep ones, and whether necessarily or not necessarily connected. I
so
originally
not all
understood.
facts about deep concepts are deep.
Yeah, that's why I asked the question about 3, because 3 looked an awful lot like if you have a deep proof, you're a deep theorem.
I see.
Which, is taking a particular stand on the relationship between deep for these different kinds of things.
I see. Okay, so on that reading of what 3 is ultimately about, then one might think that this is about the math and not about us after all. Of course, we don't have an independent characterization of the deep theorems yet, but insofar as we did, I'm sorry, of the deep proofs yet, but insofar as we did, we would be able to identify the deep theorems.
Yeah. But it wouldn't settle one way or the other. Whether it's about us or about mathematics.
Alright, so I'm gonna write down over here 3 double prime. Triple prime. Yeah. Deep theorems are theorems with deep proofs.
Which
Well, then I've got
implication does that go?
to-
No, I object to it.
But so then we're claiming from Oslo's theorem was deep because it has a deep.
Well, so we don't have to agree with all of these, right? We're just putting up things that people have said.
Maybe put an upside down question mark between the ones that lots of people disagree with.
I see, okay, so
Don't know, I was joking.
I don't even think I could draw that.
Let's do it in
Can
turn.
I raise a problem with that one, which is the elementary proof of the prime number theorem? We have theorems that pull things differently together, and we have bare hands proofs of some theorems. Bare hands proofs. Right? You just somehow
Brute force.
brute force grind it out. Nobody wants to say the proof is deep. When I say long, complicated, horrible, so they don't say deep. But it's 2 proofs of the same theorem. And I want to know how your criteria cuts on that one. I'm not unhappy with the idea that if it requires a deep theorem,
It requires a
deep
deep
proof
proof.
then it's a deep theorem.
If the deep proof exists, then the theorem is deep. Not all of it's proof.
But you might run it the other way around. I mean, you could imagine someone saying, look, sure, we used to do it with all this grand theory, right? Because the 19th century guys were hung up on complex function theory and they loved it too much. We've moved on, we've left it behind. Look at this. Bare hands proof, it's so much simpler. I don't think we on this planet do it, but my Zorgian friends do. So now we have
So to
an
be
ambiguous
clear,
case.
I think 3 triple prime is false.
Well, that's good, okay.
Right, but that was my reading of 3. So but I mean, you probably want to say you can have both deep and non-deep proofs of a deep theorem. You could say that independently.
Yeah.
But then, in this case, all that would mean is that you can have non-deep proofs of deep theorems.
Yeah.
What it means is there are also deep proofs of them, is what you want to say for 3 triple prime. It's not that all proofs are deep, it's that some proofs are deep.
So, yeah.
But you could have
Well,
it
just for-
prove a trivial theorem.
Right.
Yeah.
That's why
Yeah,
it's called.
yeah.
So
But
presumably-
just for clarification though, I think it could, at least seems to me, clear that just because there's one deep proof of a theorem, I mean, the proof in the book is kind of a compelling metaphor, but it can be misleading in some ways. I mean, it seems perfectly okay to me to say that both the elementary and the analytic proof of the prime number theorem are exceptionally deep, just in different ways and for different reasons. You ask, well, is the Gauss lemma proof of quadratic reciprocity or the one involving cyclotomic extensions deeper? Well, geez, I don't know, they're both pretty, Gauss, I think, thought the Gauss lemma one was, and Dedekind, I think, thought the cyclotomic extensions one was. I'm not going to argue with either of those guys about these things. So just, maybe this is already taken for granted. I just thought it might be worth mentioning that you could have lots of different deep proofs of the same thing, deep in different ways.
So I think maybe the box parts 1 and 2, not apparently, in some sense could apply to any of the things listed and don't necessarily imply relations between them. And it does seem as though on that criterion you could have a totally trivial proposition which is proved in a way that links things in links unrelated areas or uses methods that link unrelated areas in a way such that the proof is deep but the fact is not. I mean, it is connecting back to this question about theorems versus lemmas and so forth. It is striking that there are a number of famous cases where the lemmas are far more important, we think, than the theorems. You might think that the lemmas were really just methods of proof on the way to the theorem, and it turned out that it was that bit that mattered most. Okay, so maybe this is a difficult way of classifying 3 prime, 3 double prime, and 3 triple prime. But we have some objections raised to all of them anyway.
It's just a modification of 3 prime.
Yeah.
I think as it stands, it's stronger than it ought to be. It seems like it ought to just have a right-left arrow between 2 parts there, because we don't want it to. Sorry, 3 triple prime.
Oh.
Because we don't want it to presuppose that you can have a deep theorem that only has simple proofs, like holding fixed that 3 triple prime is really false. It still shouldn't require that a deep proof has to have a deep theorem has to have a deep proof. So it shouldn't be deep if and only if deep proof exists.
And most of these are independently. Some are necessary, some are sufficient.
Yeah, right. I'm just trying to clarify what the condition, like, we can get rid of
Okay, so you want to say having a deep proof on 3 triple prime implies it being a deep theorem, or being a deep theorem implies that's a deep proof?
the first.
Okay.
The depth of the theorem is at least as great as that of the deepest proof.
Well, I would say that if a theorem did admit of a deep proof, that would be a deep fact about it.
If it's
Yeah.
false, is that not?
This is like a characterization of what I can say.
I would think this implication is not true.
Yes.
Alright, so.
Yeah, not endorsing.
No, I think you just clarify.
Yeah.
Okay. Yeah, this was actually a question I also had. What's the
No, this is so not true, you don't even want to be in the same room with it.
I don't think we're supposed to be endorsing any of these.
Okay.
But in any case,
That's what I wanted to check.
I think that this is a different upside down question mark than one sometimes sees in other contexts. But it's yeah.
We have 2 points. One, we had a joke back here that postmodernism is a deep proof of trivialities. But the more substantive point is we're being very courageous in trying to attack these questions that are so defined. almost intrinsically, but there is a well-defined mathematical theory, at least upon the concepts and constructions, that tells you which ones are important in mathematics, or at least outlines a large class of are important, and that's category theory. And the universal mapping properties in category theory pick out of all the examples of a certain property the ones that are paradigmatic or represent the concept in the most essential way, and that essentialness is actually realized in the morphisms of the theory. And adjoint functors pulls us together with the notion of natural transformation. So this is a precise mathematical theory, and it has had considerable success in picking out what we all know are the important concepts of the important constructions.
So
But
something like
it's
that.
interesting, just to add to this, interesting the way philosophers have, and category theorists themselves have gone to war with set theorists about this. And set theory, or say model theory, doesn't do this. If you look at the natural numbers as a relational structure, you look at some just totally off-the-wall relational structure with weird relations and weird functions, you need something that says what's so important about the natural numbers, what's so important about the rations, and that's what category theory tells you. Yet, when it was first developed and introduced into philosophy, there was this contest about what's more fundamental, category theory or set theory. And the set theory certainly gives you a way to construct, sometimes in not very perspicuous way, the concepts of mathematics. But in category theory, was sort of envious of that and tried to mimic that, and then Topos was finally developed, and he said, oh, here we have it, that Topos finally showed us how to do all this. But there were a lot of category theorists and others who said, this really misses the point. That's not the role of category theory to give you some sort of primitive combinatorial concept by which you can construct everything else. Its role is to pick out exactly what is important, what is essential, what is deep, if you want to use that language there, and interesting. And so you often get category theory, misdescribed as something that's just a language or.
So can you use number 6 independently of prior judgments about depth? So for instance, if you give me a functor, does the existence of a left or right adjoint functor imply that there's something deep?
Yes, it implies that there's things on each end that have universal mapping properties.
Right.
So if all the
So anything that can be defined in terms of a universal mapping property then would be deep.
It's a type of picking out what is important among all the instances of this property, the one that is essential, the one that is canonical, the one that is universal. And it defines what universal means in a very precise way. And it's both ways. Something has the property if and only if it has a unique relationship, factory through, universal and vice versa. and if something does factor through the universal, then it has that property. So it satisfies what we call an extensionality statement. You have the property if only if it has a certain relationship of participating in this concrete universal. Because here the universal has the property in this, so it's a concrete universal. And very different. In fact, you could go, and this is a longer story, but you can also go back into the creation of the set theoretical paradoxes, and you say this happened because people tried to have a theory of universals without rigorously separating universals that have to be more abstract than the instances, those which are among the instances themselves. And the paradoxes were only taken away when abstract universals were created, always with being some higher level, rank, or type than the instances. Whereas category theory is the other theory of concrete universals, which single out the paradigmatic instance of a certain property.
So I want to go back to something that Andy said earlier. So when you start out as a mathematician, you have this idea that you know what depth means, that everybody knows what it means, and it's something objective. And then as you stay in the field, you learn eventually that no, it's extremely subjective. It's the community making a decision about what depth means, and it's really led by the powerful people, and that it's really a social construct. And one thing I think I'm kind of learning from this is that what we're doing here, so I was hoping, well, it'd be really great to strip that all away and see, what does it really do? What happens when you strip it all away? Is there anything left? But this process is making me think, well, what we're having here is a social construct. Once we agree on something, it's what the community has agreed on based on maybe the power dynamics in this room. And is that any better than mathematicians saying, well, we know what it means? Why not let the mathematicians decide as a community what depth is? Is it any better to have a different community, an outside community, discuss what depth is? And it's still just a social construct. We're not really, all we're doing is saying.
Sorry, what was the argument that it's just a social construct?
The argument that's a social construct is, well, that's an interesting question. So it's sort of what you were saying. We're all told that certain things are important, and so we all agree that certain things are important, and certain things are deep. And it's a question of the leaders of the field, the powerful people who are saying. So, Dick Rose, Barry Mazer, Don Zaghi, they say something, and these are the people, they're the people that people listen to, and they say things are deep, and everybody goes along. Now, it's not totally true, because if someone like that then says something ridiculous, and they say something deep that obviously isn't, the community will say, well, that's nonsense. So there's presumably something there, but, maybe not, again, the mathematicians will read the community back up, and the longer you're in the field, the more you realize that depth is really.
So it has more to do with the recognition of your result, and not necessarily, whether a certain result is perceived as deep or not. There's certainly areas of mathematics that are more popular than others, and that very much depends on what the leaders in the field say and what kind of areas they push. And I would say that.
But they'll say it's more, it's more important because it's deeper.
No, they wouldn't say that. That's.
So I think we can agree that that's within us and also context dependent. And mid-definition by adjunction presumably is neither, but it's also, I guess I'm still unclear about, so it certainly does seem striking that at least many of the definitions, concepts, at least constructions that do turn out to have significant organizational power do seem to have natural seeming definitions in terms of universal properties, but it's not clear that every universal property is deep. And so I guess Marc suggested another sort of orthogonal way of classifying things is in terms of properties that we generally expect deep things to have. But I think that surprising, so I need another symbol. Anyone want to suggest another symbol? Hash. So surprising and transformative presumably fall into that category. Fruitful presumably also falls into that category, although I wonder if there's a sense in which fruitfulness sort of like, the hashtags correspond to things that are perhaps not constitutive of depth, but we believe to be somehow, we expect deep things to be characterized by. Does that make sense of the distinction? I'm sorry? That's going to require me to remember something. Okay, so exclamation point meant about us in the Geroch sense, as opposed to be distinguished with from about the math. And question mark was context dependent, in the sense that so for instance, whether or not something is hidden, it may be hidden before our epistemological status might affect whether or not something is hidden. Star was, we think, about the math. So without this ledger, I had complete leeway in what I wrote up here. This symbol, which I invented, meant almost certainly false. And this meant characteristic but not constitutive of, or something like that.
Which means what? It means if that's true, then things are deep, or if
Other way
that's
around.
true,
If something is deep, we think it probably has this property, but something having that property need not imply it's deep. And I guess then there's a question that I was going to ask about whether people thought fruitfulness was even potentially of a star character, or if it was only a hashtag.
Actually, I had an antecedent question earlier, and I guess I wanted to answer it because I believe it's relevant to some of what we're talking about as to whether we really can say what deep means. So there was a question that I had that I couldn't, a problem I was trying to solve. And I went around asking various mathematicians. And if I simply asked them the question, it looked like something that, well, a lot of people seem to think it was obvious. And they say to me, oh, Alice, that's obvious, that's trivial, that's really easy. And I say, okay, that may be true, but I don't know how to do it. Could you please explain it to me? And they start trying to explain it, and they discover, no, in fact, it's not obvious. And they say, well, I'm sure it's obvious, but I don't see it. And I asked the top people in the field, and they were better than these other people I've asked. And they would get, they didn't have that reaction. They would get stuck and say, well, I don't know how to do that, sorry. And then I would go and ask other people this question when I realized that, I'll cut to the chase rather than wasting all this time having them try to tell me it's obvious when it wasn't obvious. I'd say, look, I asked Mazer and Tate and Sam, and they didn't know how to do it, but I know you're in this field, and I thought maybe you would have some insight into this. And at that point, they'd say to me, Alice, that is a very hard problem. Example of the things I've been seeing in mathematics. That's a very deep problem. It depends how you, so then my question is that a deep problem or is it a non-deep problem?
Is what the problem?
Well, I was asking them, given this, do we have evidence, if we look at our list, can we say something about, the famous mathematicians couldn't do it, but the second and third tier said it was trivial, and in some sense, has the community spoken, what does this mean, what is this telling us?
But have we learned then that the problem is in fact hard and that mediocre mathematicians are bad at determining how hard problems will be?
No, eventually I found a really good
mathematician
who was not one of the top people
Yes.
who was willing to take the problem seriously, who decided it was about the math. It wasn't about who was asking the question, and it wasn't about who had been asked earlier. And we started looking at the problem, we realized, well, there was a statement about, this always happens over every field, and we learned, well, this, the answer is different depending whether it's a finite field or a number field or a function field or whatever. And you start, solving the problem. So it was a problem that could be maybe partially solved, but not completely solved. And, I'm not sure that one can, these things are very contingent on who's asking the question, who's answering the question, how seriously it's taken, what is happening historically at this time as to whether this field is considered important or not.
I think it's really important to pay attention to these two senses of depth that were highlighted earlier, like this idea that it's hidden or that it's difficult to get to, which is what you're really talking about, which I think we can agree has a lot to do with our abilities, and then this other kind of depth that has to do with its ability to connect up these different areas of mathematics. Like Jamie was talking about, we set up the rules, as it were, and then based on how we set up the rules, it's just it just objectively sort of follows from that this theorem connects up these different areas or something like that. So I think you can be entirely right that when we're talking about this one kind of depth, we were talking about depth in the sense of being really hard or difficult or taking a lot of effort, and that might be something that's totally socially constructed. but then I think there is this deeper sense of depth. But which Jamie was bringing up, which I think is a really important one for us to grapple with.
So you can, I just want to observe that we're 10 minutes over time, so we should stop soon. Maybe, Kat, you want to make a remark on the one?
No pressure.
Actually, I just wanted to ask, so when you brought your question to these people and I said, oh, that's so it's obvious, I got this. They were like, oh, that's not so obvious. Did they continue to say that's not a deep problem, or did they say, oh, I know now, consider judgment as a fact, this is a deep problem, or were they just like, I don't know what to do with this?
So sort of different questions. I presented the question differently to different people at different times, as I sort of learned what was happening. You know, partly it was a sociological experiment, partly I wasn't really answering this question. So if I just simply said it as, I have this question I want to know, they would say it was obvious, and when they couldn't do it, they'd say, well, I'm sure it's obvious, but you know, I don't have time to do that specifically. And that was that. And otherwise it was, you know, this is really hard, and you know, that's all I can say. This is really hard because these other people have thought about it, and it was a really deep problem. But I guess I will maybe add to that, as a woman in mathematics, I learned that it's better to work on problems that have already been certified as deep, because if you just simply solve a problem, it will be certified as not deep if the person who can solve it doesn't know. So you want to work, I mean, the advice I would give to women in mathematics is it's a lot better to work on something that other people have tried and failed to do and have determined to be a hard problem. And you want that to have been on the record so that you then can actually solve it.
Yeah, so that's better data. Good. I was worried that like it would end up being the case that people's intuitive judgments of depth were simply misleading, and we ought to rely on those. But if it's in fact the case that even given considered judgment, people are still people who ought to be experts on something are still inconsistent, then maybe there's something worrisome. Although we should, I mean, maybe we don't want to expect that like those even experts' judgments are going to be reliable with this until we've actually got some proof on the table.
So let's thank today's speakers one more time.